Our next speaker is Bahadir Emml from Cadence Design Systems. He's Group Director there of Verification Application Engineering. And he's going to speak about engineers, logistics, and AI. As I say, he's a Group Director, team based primarily in California. Before joining Cadence, Bahadir held several senior engineering positions at consumer and biotech semiconductor companies, and he's personally based in San Diego. Holds degrees in electrical engineer from a Middle East Technical University in Turkey, as well as Caltech. And over to you.
Cool, awesome. Good morning, everybody. So far, Vivek and Alex talked about all those scary things about how difficult our jobs and our lives are. So I will hopefully bring some relief by the end of our conversation. So, but let's take a look at the general trends. And I'm going to say, as the usual thing, there are only 10 marketing slides now. Anyway, so we'll get to the technical slides too. But we're all aware of the general trends on all of these things. 5G, a lot of 5G people over here working on the cutting edge technology. Data center cloud, really important. It's been there for quite a while, and we keep working on that, and it gets bigger and bigger. Now, hardware accelerators. This is one of the new things in the last the trend 7-8 years, and that's how a lot of companies that didn't used to do any hardware in the past, we are known for their software, got into hardware design and development. Autonomous vehicles. Should I say anything more? But we'll talk about that a little bit more. And then industrial IoT. Among all of these things, industrial IoT I consider to be the easiest one. But of course, like someone will probably take me out to the parking lot for having said that, and we'll see that. So this is why our job is getting more and more difficult. Now, the trend has been going on for a long time, right? And the expectations are annual designs in the next 10 years, 4x, right? 4x. Now, this is not that, the design cycle at this point, we're really skinny on the design cycle. Like we're down to, getting taping out large mainstream chips of, a few billion gates in a year, right? But then what the trend is like, we're getting assigned to more and more projects at the same time. Oh, you're done with that block, so I need you to work on this one as the derivative now, and the other one, and then you need to also go back and do close the do coverage closure with your original one. So this is the thing. Now the transistor, the chips are getting bigger and bigger, 100x over the next 10 years. When I first started out of grad school at AMD, the very first chip that we built was a fully integrated Ethernet switch. That was the first one didn't work, but the second one worked. But that was 8 million transistors. We didn't know. Now we're talking about billions of gates and 100x over the next decade. The complexity of all of this is incredible. And guess what? So I hear that there are some students over here. Those, raise your hands. Okay, one. We need more of you people. This is. I actually talk at universities also, and we're now encouraging universities to get into digital design verification topics more and more. So far, it's been mostly analog. Everybody graduates thinking it's all analog out there. You know what? No, the digital world is even bigger. And now, in addition to all of this, look at the new things that we're getting, right? But we have new things that we need to do. Some of these, Yeah, Vivek talked about, I mean, he didn't quite, I don't think he was able to scare you enough about the functional safety verification. The functional safety verification is really scary for me. I know I did it myself, and I led our North America team, expert team for a while. The way I think about it is that the verification burden, for the functional, regular functional verification, the verification burden is, 1. With functional safety, with ASIL BC, you have an order of magnitude, like 10x, it becomes 10x. With ASIL D, we're talking about 100, possibly 200, maybe depending on what you're doing, 1,000x. That's a lot of simulations, a lot of runs at low power, power aware, right? A lot of us now live and die with our battery life. So this is critical, and this is significantly more work in terms of all of the complexity of the power domains and what goes, the scenarios, and out of hundreds of power domains, what happens if this, the cache is off, and that. So this is all adding. The usual, I noticed that on this one, they took out the x-axis because I think it's the same graph that I've been seeing for the last 25 years. But, I won't even speak to this one. So, the saying, amateurs talk about strategy, professionals talk about logistics. It's generally attributed to Omar Bradley, but probably not the first one to say it. It's been said a lot of different times. It is, regardless of who said it first, it is very, very meaningful. On the talk about logistics, I actually like Alexander the Great's quote on this one. He said that my logisticians are a humorless lot because they know that if this campaign fails, they will be the first ones I will execute. I haven't figured out a good way to put that into an engineering presentation. I'm working on it. All right, UPS. Logistics. That is what they do the best. Now they have the engines, right? These are the engines. We're going to talk about engines with the van, truck, plane. But the important thing is when to use the best engine to optimize the end-to-end, to optimize the overall work burden. So this is a linear programming, problem. And the linear programming had come a long way since the days that I was a graduate student, and it was the early days of its application in the industries. But this is what they do the best, how to put it all together so that they use the best engine at the best time for an optimal performance. Okay. Some of you are familiar with this. We're doing the same thing. Best engines, Helium, simulation. But look at these, compile time in minutes. Speed, about 100 hertz. Reach IP debug, best places. Now, Palladium, speed, 1 megahertz plus 1 megahertz. We can work together to get it above 1 megahertz, right? This is significant speed up. Compile time, a few hours. Okay, I mean, I can get a billion gate SoC compiled, ready to launch in around 5 hours. I'm saying it because, it's like one of the recent work that we're doing, 5 hours, that's great. SoC debug, because SoC billion gates, you put it on, it runs on Helium too, beautifully runs. It's just that you can't run long scenarios. You can't run long tests. You cannot do, OS boot and stuff like that in a reasonable amount of time. Reasonable amount of time being, I would like to get some results in a few hours. And then Proteum, right? So now, 5 megahertz plus, really fast. Software debug. So in the past, software engineers were okay working on Palladium. Nowadays, it feels slow. So there, this is the engine for software development. Compile time, 1 to 2 days. So trade-offs. And the important thing, when to use the best engine at the best time. So the logistics. All right. So this is what we're now doing, and adding more Jasper, formal, putting in formal at the right time reduces the verification burden for the other engines. And there are a lot of things that Jasper does beautifully and very effectively. And then Helium. Again, so Jasper addressing the verification problem, Helium addressing the software development problem. The earlier you can start your software development, the better life is. And with Helium, you can now start your software development. You can get your software engineers busy even before you have even a few lines of RTL. And all of this, again, working together, intermixed at the right time, together with the logistics, the best logistics, run, coverage, debug. And then on top of that, adding things like mixed signal and functional safety, power aware. Talk about mixed signal. This is kind of just a starting point. AMS versus DMS. With the AMS, with Spectre and everything, you know, simulation, analog engine works beautifully. Accuracy, but slower. So now you go to DMS with the real number modeling. Now, trade-off, significantly faster for some margin on the accuracy, but significantly faster. And you can have the unified debug and test bench and coverage across the whole thing. So with this, you're getting the best of both worlds, both the accuracy and the speed at the right time. Now, the hardware, simulation acceleration. Again, the overall the trade-off between speed of execution and the debug. And the most important thing is that with the overall congruency, they actually, that's why they call it dynamic duo, they work together hand in hand. Now, you're doing verification with the Palladium. So custom processor, very nicely done, connected with an interconnect overall for all of those. So it is very gate level like and much faster than simulation. So you can do long tests, complex tests, etc. on the Palladium and have the full visibility of a simulator to debug. Again, full visibility of a simulator because it is custom processor based. On the other hand, with Protium, with the FPGAs, they are a little bit, and so it takes a little bit longer for build, but very smooth transition from the Palladium database to the Protium database, and you get 3 to 5x speed up. Beautiful for software development. The congruency, you're doing software development, you're running test cases, you run into a fault, there's a bug, right? Now what do you do? It's like FPGA debug, for those who have done it, is painful. Especially once you're used to the full visibility of a simulator. And I'm like, what? I need to trigger and I need to come up with my probe points and stuff. God, like, oh, I missed it. I need to rebuild everything for the new. Congruent. Take the database, run the same database. It is guaranteed to run in the same way on the Palladium, debug it with full visibility to all of the signals, find the bug, fix it, recompile it, put it back on the FPGA, and your software engineer is good to go, right? Verisim Manager. So V Manager, for those of us. Now V means Verisium. It used to be verification. V Manager. This is the connectivity of all of the engines. Let me take a look at the time. Yeah, okay, right. I need to keep looking at the time. Otherwise, before we know it, it's going to be, the sun will be setting and we'll still be working through slide 10. So Verisium Verisium Manager connects all of these engines together. It will go ahead and work with Jasper. It will work with Helium. It will combine your results in terms of coverage and other goals, and it will provide the ability to optimize how everything goes together. Remember, logistics, best engine, for the best time, best task, and vManager makes this possible overall. So, this is multi-site, multi-project, works on the, on the cloud, and handles things like job scheduling, and provides a smooth transition and smooth interconnectivity between all of these engines. Functional safety. Thank you, Vivek, for going first. This is the functional safety. Functional safety, like I said, depending on your ASIL level, it can be a nightmare. Yeah, okay, I will stand behind my words. Because there is a lot of work that needs to get done to be able to inject all of those faults, and the faults can be a significantly huge number. And to get those faults to the observation points and detection points, etc., and then when they don't, rerunning with different tests with different seeds, it is a huge amount of additional work on top of your regular verification, functional verification. So what do we do? What did we do for this one? This is a beautiful example of how logistics help in this fashion, because Jasper, in this case, can find a lot of the faults that will not propagate to detection points. So these are your safe faults, because they will never get out, injected, and it will never get to an observation point. Now, simulation, fault simulation, you can inject as many faults as you want. But guess what? These safe faults will never get to the observation point. So you're injecting these into the simulation in vain. Okay, so if you run Jasper first, find these, and then take these faults out of your fault database and not inject them, your efficiency goes up sometimes 60, 70, 80%, because a lot of these faults will not propagate. vManager, together with Midas, where you provide your FMEDA, automates all of this process. So it runs, goes ahead and runs reachability first. From the reachability, it determines all of these remaining faults. It runs the fault simulations, injects the ones that, that just automates the test. Whatever the faults provide results, they're added to your FMEDA. If they don't, they continues to automatically run other tests until the whole thing is exhausted, and all of the results are provided to you in the reporting and provided for certification. This is a beautiful example, one of the first examples of how we were able to put all of these together. But is it enough? No, unfortunately not. Which is good, because we're still employed. That's, it helps us. Let's talk about now AI. What are we doing next? What's coming up? What is available? And what can we do going forward? So thankfully, we are, at the front edge of the AI ML revolution. And just like ML helped robots like Boston Robotics to be able to do all of those cool stuff and dance and stuff like that, it's helping us with verification also. So when you go back to EDA 1.0, what do we have, right? We had different tools, spot tools to do different things, place and route, and logic simulation, and synthesis, and or analog simulations, etc. Spot tools, right? And they all had their own quality of results, capacity, runtime, etc. So that's what we did. From a user point of view, this is what we do, right? This is what you do every day. That's what we do in general every day. Different teams run tool A today and tomorrow and the next day, and just are over and over. And then the other team, simulation team, the verification teams runs the simulator, regressions of hundreds of thousands of test cases every day. And then analog team, just fires up Virtuoso, and they're running their analog simulations and stuff. So they're all running every single day in their own environments. But, and as Alex was talking about, there is data here that we can take advantage of, that we can share between teams. And we can, if we were to put all of this data in some environment where tools or even the scripts that we write can work on that data and find the efficiencies and optimize those efficiencies, provide information from tool to tool, our lives will be significantly improved. And then they'll give us more work to do, right? Now, that is what we are doing right now as we speak. So we developed the Jedi. I still haven't found who came up with that name, but it's pretty cool. This is one of the coolest things that our marketing did for us in the last 10 years. So there is the Jedi Data platform. All of these tools can talk to Jedi. So you can see Cerebrus, Verisium, Virtuoso, Optimality. These are all different tools from different BUs, because Jedi is the common platform for all of Cadence. All of the BUs now are tasked to work with this. And they put their data. They are also allowed, allowed to or required to see what they can do with the data shared by other tools. And they're coming up with a lot of different concepts that are becoming really useful. For example, just think about power estimation, right? Power estimation, the most accurate thing, power estimation, is on the gate level, but gate level takes much longer to run if you're simulating it. Well, now Genus and Xcelium can work together so that from the Genus environment, Xcelium gets information to run RTL simulations with accuracy nearing gate level simulations. Of course, RTL is much faster, but it's using the timing and everything information from Genus, and it's able to run simulations to be able to do power estimation much faster. And Verisium, we're going to talk about Verisium in terms of what it can do, right? So again, best PPA, highest coverage, and fastest time to market, trying to find all the efficiencies using both AI and machine learning. Let's take a look at the Verisium AI-driven verification, debug. Right, take a look at this. Now we're going to address different sections of it. I think Alex also showed this graph. So debug, 41%, simulations, 24%. It's data. I don't completely agree with it, but close enough. 5 minutes. Okay. So wow, that's not what this says though. So all right, I'm the only one standing between you and your break. So I will try to wrap it up in 5 minutes, and you can ask me questions afterwards. Now with Verisium, we're addressing the debug section. Debug takes a lot of time. It's like our job is to find bugs, right? That is what our job is. Really, our job is not coverage closure, which, a lot of, companies seem to think. Our job is to find bugs. Everything else is just collateral. So you run the test case, it fails. Now you have to debug it. And a lot of us are very good at debug, but what if we could get the tool to help us in the way that, just like you have senior engineers that you go and ask questions to, because curmudgeons, I became one of them, just like, so I am the curmudgeon that some people come over to ask me. But we have these people that we can go and say, hey, look, I am getting this error, and what do you think? And he looks at it, or she looks at it and says, did you look at these? Check these 3 signals. I've seen this before, because they've seen it before. They have very good pattern recognition. And then you go back and then you look at those things. Oh, yeah, that's an X. Oh, why is it going an X? Let's go find it. And then, 15 minutes later, you find the code that is causing it. That's what WaveMiner does. That's what WaveMiner does. You gave WaveMiner so your test case failed, right? You ran it last night, your test case failed. You have the waveform. The day before or 2 days before the test case passed. Or maybe this is the first time you're running it, but there is an adjacent test case that you ran and it passed. You have the waveform. You give it to WaveMiner. WaveMiner analyzes the passing and the failing, and it tells you in priority order 2, 3, 4 signals to start with. It is giving you a starting point that is closer to the source of the bug rather than starting from the error condition and going all the way back. Significant improvement. And this is what we do, how we do debug after like 2-3 weeks into the project. Now we can do the same thing. The tool does it for us from the very beginning. Now, pin down. People are checking in code. Like, in the last 3 days, like 10 people checked in, 2, 20, 30 pieces of different blocks. And last night, your regression failed. Whose code? Which check-in? If you can identify that check-in, your debug becomes significantly faster instead of trying to debug. Pin down does that. Analyzes, and then it predicts which check-in. It's not just a matter of the binary search. It actually has very powerful predictive AI algorithms, and about 70% of the time, it identifies the bad check-in in the first try. About 90% of the time in 2 tries. Okay. And where is semantic diff? Okay, semantic diff is not on that slide. Semantic diff, in a similar fashion, identifies unlikely thing. Some of you are familiar with Helium ML. Now, Helium ML is addressing the runtime. You have a regression of 100,000 test cases. Is that an optimal regression? It takes a lot of compute time to run that. Can you be running something else instead? Helium ML looks at the coverage as the goal, looks at knobs, that knobs are primary random variables and test cases, and out of these, it synthesizes you an optimal regression. The optimal regression gives you 3x, 5x. I have seen, so it says, does it say 30x over here? It doesn't. Yeah, it does. Well, actually, this is not. So I saw on some of the slides, it says 30x. I've seen 42x as the, okay, so see, this is the reason why they don't give me they give me a microphone and then they cut the microphone off. So with Helium ML, you can speed up your regression significantly. Like again, the best I've seen was 42x, and the user also admitted, yeah, that's an overstated regression. But still, provided that answer. And Now you have additional compute time to do possibly other things to get to your coverage closure faster. In fact, with XLM ML, you can do all of those things. And finally, Jasper. Let's talk about briefly Jasper with the AI. So there are a lot of things that AI and ML can do for you. Learning pattern recognition out of large groups of data that is not humanly possible to analyze is what ML and AI does best, especially in terms of ML. So for the Jasper proof master,
we do need to finish. Let people go.
Okay. So the important thing is, all right.
Move to your last slide then, please.
So look, if looking at the results, when you go with the Jasper proof master, significant improvement in terms of the results, because things that we would see as patterns, it sees faster, better, and it can implement these. I'll skip this one and the overall solution. And so you can blame him.
Okay, so thank you very much. Thank you very much for the talk. We're back in here at 11:30. Remember, if you're going to the training session, you're in room C. If you're going to AMS, you're in room D. Okay, and coffee and snacks should be out there. I guess if you want to ask questions, I'd come to the front. We've run out of time for a Q&A now. But,
any questions? Okay. I'll be around all day.
And they'll be at the booth as well. Cadence will be at their booth. Thank you very much. Thank you. Thank you.